Okay, averagey velocity stuff. Okay, so here's a parabola equation. Find an average velocity from 1 to 3. So basically, I need you to be doing this. 1 comma what? Can you plug a 1 in? 3 comma what? Can you plug a 3 in? So I got a 98. That one. 254. Okay, so how do you find the average velocity? Velocity is a slope. So what's a slope? y2 minus y1 over x2 minus x1. And then we're going to put some stuff on the end of that number, though. In what? Meters per second. So visually, this is an upside down parabola. From 1 to 3, this is what I did. From 1 to 3, I got that. And then it was trying to estimate a velocity. Okay, next, estimate instantaneous velocity at 3. So now I would really like to know, this exactly at 3 instead of this, because this isn't as good, right? The more space you have, the farther your estimate is. So I'm going to estimate, so here's what we're going to do. We're going to do the close number game. So I'm going to go 2.99, and I'm going to go 3.01. Are you okay if I tell you these numbers instead of your calculator?
Yes.
253.3195. Ready? 254.6795. Okay, give me a y2 minus y1. Did you get 68? So this velocity would be closer to the velocity at 3 than this one, right? This is just a guess, but this is a better guess because we got our points closer together. The space is getting closer to 0. Instantaneous means precisely only at 3. So there's no space between the points. So what do I want to do? I want to find the slope. Shortcut. Can you derive this equation using that shortcut thing? Times go down, times go down. Times go down, times, and then go down, which isn't anything then. Is that the good equation? Is that what you got? Now, what are you doing? Putting in a time of 3. So our really close estimate number thing was very much bang on. This is exact. It's specifically instantaneously at 3. Okay, so do you want to do another one of those? Is that okay if we skip it? Skip it? Are we okay? Y2 minus Y1. Okay, so give me an instantaneous. I need you to derive this equation. So H prime equals negative 10t plus 60 So now, at the time of 4, what is your velocity? Okay, so there's your visual. At the time of 4, this is where I am when I launched an object or whatever, right? So I launched an object at the time of 4, it's at a velocity of 20 meters per second. Okay, find out when does this object reach max. So there's the max. So you did this in grade 11. In grade 11, you did negative b over 2a, plug in, that kind of stuff. Okay, obviously we could do that, but we're going to use derivatives. Okay, what do you know about the instantaneous tangent slope right there, like that? The slope is going to be 0. Do you see it? So 0 equals negative 10t plus 60. That's my slope equation. I'm not using my equation of the height. I'm using my slope equation. So at 6 seconds, it's going to reach that top. And what is the max height? So I'm going to plug in 6. Where do I plug in 6? Should I plug it into the slope equation or the equation at the start? At the start, because that equation tells me height Does this make sense? If I'm saying this equation tells me height, this equation tells me velocity. Once I've derived it, it's now telling me about velocity. Okay?